So this is the second video on LU decomposition method of systems of simultaneous linear equations. To watch the first solution video, do well to look at the comment section of the video and you'll find a link to that amazing video. Now let's solve this question. The question says we should find the values of x, y, and z when given these systems of equation. Now in the first video I said to solve using LU decomposition method, we need 5 equations. The first equation is labeled as A V is equal to B. That's our equation 1. Now we simply decompose A into a lower and upper matrix. That's our equation 2. Now once we decompose A into a lower and upper matrix, we replace that into equation 1. In place of A, we now have the lower matrix multiplying the upper matrix multiplied by the variable matrix B, and that's equal to B. This is equation 3. Now B is the constant matrix, V is the variable matrix, and A is the coefficient matrix. Please keep that in mind. Now, over here I said we don't want 3 matrices multiply one another, hence it becomes difficult to solve. For that reason, we simply say let Y be equal to UV. This is now equation 4. So if Y is equal to the upper matrix multiplied by the variable matrix, then if we fall back now to equation 3 and plug in UV as Y, it means we're now going to have, in place of equation 3, now we have Ly is equal to the constant matrix B. This is equation 5. Now this is the 5 distinct equations that we need. So first is to start with the first equation, decompose or convert this system of equation into a matrix that involves the coefficient matrix, the variable matrix, and the constant matrix. Now what are the coefficient matrix A? A is equal to, so we pick the coefficient of each of the variables. The coefficient of x in equation 1 here is 3. So you have 3. For y we have 2. For z here we have 7. So we'll do the same thing for the remaining 2 equations. So for x here we have 2. For y here we have 3. For z here simply 1. Finally, for the equation 3, for x we have 3. For y we have 4. And for z we have 1. So this is our coefficient matrix. Next is the variable matrix V. This is going to be equal to, and this is what we are looking for. These are the variables or the unknowns, x, y, and z. So the variable matrix are x, y, and z. Finally, our constant matrix B represents the constants 4, 5, and 7. So we have 4, 5, 7. So this is our constant matrix B. So that's the first step. We've broken this down now. The next step is to convert the coefficient matrix into a lower and upper matrix. So that means my coefficient matrix becomes, this is now my coefficient matrix. We have 3, 2, 7, 2, 3, 1, 3, 4, 1. And this is going to be equal to the lower matrix multiplied by the upper matrix. And the lower matrix we said is going to be 1, 0, 0, 1, 0, 1. So this is our lower matrix. For the lower matrix, the upper elements are 0. Meanwhile, the measured diagonals are represented as 1, 1, 1. Now, the remaining matrix are unknowns. So we can call this A, B, C. Please do well to watch the first video. I took time to explain all of this in the first video. So this is our lower matrix L. Now, this lower matrix multiplied by the upper matrix. For the upper matrix, the lower variables are 0, or the lower elements are 0, 0, 0, 0. But now we fill up the upper matrix with unknowns. So this is A, B, C. We start simply D, E, F, G, H, I. So this is our upper matrix, U. So this is A, by the way. Matrix A is now equal to the lower matrix multiplied by the upper matrix. So our aim now is to find the values of this unknown and then decompose A into this lower and upper matrix. So we start our multiple then. This is now 3, 2, 7, 2, 3, 1, 3, 4, 1. And this is going to be equal to, so we find the product of this matrix. So we use the first row to multiply the first column. That gives us the first element in column 1. Okay, so for the first row now it becomes 1 times D, which gives us D, plus 0 times 0 is 0, plus 0 times 0 is 0. So it means we'll have just that element in column 1. Again, to find the next element in column 2, we still use the first row matrix to multiply the second column now. So it becomes 1 times E, which gives us E, plus 0 times G, which is 0, plus 0 times 0, which is 0. Finally, still the same row, multiply now by the third column. So we have 1 times F, that also gives us F, plus 0 times H, 0, plus 0 times I, which is 0. So we have this. Next, to now find the second row, we'll move to the second row, use the second row to multiply the first column, second row multiply second column, second row multiply third column. That gives us the elements of the second row. So now we are going to have A times D, which gives us AD, plus 1 times 0, which is 0, plus 0 times 0, which is 0. So we have this. We move now to the second column, A times E, which gives us AE, plus 1 times G, which gives us G, plus 0 times 0, and that is 0. So we leave it there. We move now to the third column. Again, A times F, which gives us AF, plus 1 times H, which gives us H, plus 0 times I, which is 0. So we'll keep it there. Finally, we are now at the third row. We'll use the third row to multiply each of the column accordingly. So it becomes B times D. That gives us BD, plus C times 0, which is 0, plus 1 times 0, which is 0. Again, B, we'll move now to the second column. B times E, that gives us BE, plus C times G, that gives us CG, plus 1 times 0, which is 0. So we'll kill it off there. Finally, we'll move to the third column now. B times F, that gives us BF, plus C times H, that gives us CH, plus 1 times I, that gives us I. So we have the matrix of that product. So when you have this, these two matrices are now equal. We'll use the condition of equal matrix to find each of these elements. For two matrices to be equal, we said that it means that the element in the first matrix at each of their distinct position must be equal to the element in the second matrix. That simply means that the element in row 1 column 1 of the first matrix is equal to the element in row 1 column 1 of the second matrix. The element in row 1 column 2 of the first matrix equals the element in row 1 column 2 of the second matrix. Element in row 1 column 3 of the first matrix equals the element in row 1 column 3 of the third matrix, of the second matrix. So you maintain this position accordingly. That is the law for two matrices to be equal. So if that's the case, then this simply implies that I'm going to have my D to be equal to what? 3. I'm going to have my E to be equal to 2. E to be equal to 2. And I'm going to have my F to be equal to 7. F equals 7. Next, we fall back now to AD. That's going to be equal to 2. So therefore, AD equals 2. But we have a value for D. D is 3. So this is actually 3. A is equal to 2, which simply implies that A becomes what? 2 all over 3. So A equals 2 over 3. And you have this. So let's take this off now. Similarly, we move down here now. AE plus G, that will be equal to 3. AE plus G equals 3. So we have AE plus G to be equal to 3. We know the value of AE. A is 2 over 3. 2 over 3 multiplies E. E is 2 plus G equals 3. So this is going to be 4 over 3 plus g to be equal to 3, which implies that g equals 3 minus 4 all over 3. Simply sending 4 over 3 over here, right? So this is going to be equal to, taking LCM now, it becomes 9 minus 4, which is 5 all over 3. So it means that g is 5 over 3. So I have my g to be equal to 5 all over 3. So we can take this off. Next, we have AF plus H equal to 1. AF plus H equal to 1. So we have AF plus H equals 1. Let's confirm that, yes. Now we know what A is, 2 over 3. A is 2 all over 3 multiplies F is 7 plus H equals 1. So 2 times 7 is 14 over 3 plus H equals 1. This simply implies that H becomes 1 minus 14 over 3. And this is going to be equal to, so 3 times 1 is 3. 3 minus 14 is minus 11 all over 3. So it means H is negative 11 over 3. H equals minus 11 all over 3. Again, now we have BD to be equal to 3. BD to be equal to 3. So BD equals 3. We know what D is. D is 3. So this is simply 3B is equal to 3. Now this simply implies that my B is going to be what? 3 over 3, which equals 1. So B is equal to 1. You can take this off. Similarly, BE plus CG, that is going to be equal to 4. BE plus CG equals 4. So we have BE plus CG equals 4. We know what B is. B is 1 times E. E is 2 from here. Times 2 plus CG. We know what G is. G is 5 over 3. So this is 5 over 3 C equals 4. So 1 times 2 is 2 plus 5 over 3 C equals 4. Let's send 2 over here. You have 5 over 3 C to be equal to 4 minus 2 gives us 2. So if you cross multiply, 3 multiplies 2, this gives us 5C equals 6. And therefore, C is equal to 6 all over 5. So we have our C to be equal to 6 over 5. Okay. So finally, we have now BF plus CH plus I is equal to 1. BF plus CH plus I equals 1. So BF plus CH plus I equals 1. What's our B? We got B to be 1. So 1 times F. We got F here to be 7. Plus C. We got C here to be 6 over 5. 6 over 5 multiplies H. We have H here to be negative 11 over 3 times negative 11 over 3 plus I is equal to 1. So 1 times 7 is 7. 6 times negative 11 is negative 66. All over 5 times 3 is 15 plus I equals 1. So let's take LCM between these two. That's 15. LCM between the two of them is 15. So 15 times 7 minus 66. That gives us 39. So we have 39 over 15 plus I to be equal to 1. So we simply send 39 over 16 over here. This simply implies that I equals 1 minus 39 over 15. So once again, we take LCM. LCM is 15. 15 times 1 minus 39. The LCM is 15. So you have 15 times 1, which is 15, minus 39. Therefore, I is going to be equal to, so let's obtain that value 15 minus 39. That gives us negative 24 divides 15. So we have negative 24 divides 15. Okay, so we can take all of this off. So we've been able to find all the unknowns in the lower and in the upper matrix. Let's now represent them in the lower and upper matrix. So in the lower matrix, I have the value of A. A gave me 2 over 3. So in place of this, I'm going to put in A. A is simply 2 over 3. Then I have B. B gave me 1. So in place of B here, we have here to be 1. Then I have C. C gave me 6 over 5. So in place of C here, we have 6 over 5. So now we know the elements in the lower matrix. We move to the upper matrix. I have D here. D gave me 3. So we have here to be 3. I have E next. Take this off. 3. I have E next. E gave me 2. So I have here to be 2. And then F. F gave me 7. I have here to be 7. Then I have G. G gave me 5 over 3 from here. So I have 5 over 3. Then I have H. H gave me negative 11 over 3. Negative 11 over 3. And finally I. I gave me negative 24 over 15. So minus 24 over 15. Okay. So now we have been able to transpose or decompose A into a lower and upper matrix. It means we have satisfied the second equation. A equals lower times upper matrix. So we can take this off now. Now, the next equation says, so if you come to equation 3, since we have multiple of 3 equations, 3 matrices here, it means we can't solve equation 3 yet, which is why we said let y be equal to uv. But now, observe that the variable is unknown, y is also unknown. Meanwhile, matrix y, keep this in mind, matrix y is simply going to be y1, y2, y3. We need to find these 3 variables for y. So since y is unknown and the variables are also unknown, then we say we simply plug the value of y back into this equation 3, which gave us equation 5, Ly equal to b. Now we know our lower matrix, we know the constant matrix, which is b. We can find the value of the what? Y matrix. So Ly is equal to b is the equation we are coming to now. What is L? The lower matrix. These are the variables. So you have L. L is 1, 0, 0. 1, 0, 0, 2 over 3, 1, 0, and 1, 6 over 5, 1, 1, 6 over 5, 1. This is our lower matrix multiplied by y, and y is y1, y2, y3. This is going to be equal to the. We are now at Ly is equal to b. This is our L. Is our y, and that's equal to b, b being the constant matrix 4, 5, 7, as can be seen there. So once again we perform our multiplication and we have a new matrix. So the whole of this row multiply this column. Now this is going to be 1 times y1, which gives us y1, plus 0 times y2, which is 0, 0 times y3, which is 0. We move now to the second row. 2 over 3 multiplied by y1, that gives us 2 over 3 y1, plus 1 times y2, which gives us y2, plus 0 times y3, which is 0. We move now to the third row. 1 times y1, which is y1 plus 6 over 5 times y2, 6 over 5 y2 plus 1 times y3, which gives us y3. Okay, so now that we are here, the whole of this is equal to the constant 4, 5, 7. So I said earlier, once two matrices are equal, it means their elements in their distinct positions are equal. So the elements in row 1 column 1 equals the elements in row 1 column 1, and that in row 2 column 2 equals the elements in row 2 column 2 for them to be equal. So if that's the case, then it means that y1 is going to be equal to what? 4. So this implies my y1 equals 4. So y1 equals 4. Then 2 over 3 y1 plus y2 is going to be equal to 5. So 2 over 3 y1 plus y2 equals 5. This is now 2 over 3. y1 is 4. So times 4 plus y2 equals 5. So this is going to give us 2 times 4 is 8 over 3 plus y2 equals 5. We simply make y2 subject. It becomes 5 minus 8 all over 3. The LCM here is 3. 3 times 5 is 15 minus 8 all over 3. So this implies that y2 is going to be equal to 15 minus 8 is about 7 all over 3. So y2 is 7 over 3. Now, finally, for the third row, the whole of this is equal to 7, which is y1 plus 6 over 5 y2 plus y3 equals 7. So this becomes y1 is 4 plus 6 over 5 times y2. y2 is 7 over 3 plus y3 unknown equals 7. So now okay, this is going to be 4. This is going to be 4 plus 6 times 7 over 5 times 3. 6 times 7 should be 42. Let's confirm. 6 times 7, that's 42 all over 15 plus y3 equals 7. So the LCM between these two, 4 and 42 over 15 is 15. So we have 15 times 40, 15 times 4, that gives us 60 plus 42 over 15 plus y3 equals 7. Okay. So 42 plus 60 is 102 divided by 15 plus y3 equals 7. So we make y3 subject. y3 becomes 7 minus 102 over 15. y3 equals, the LCM is 15. 15 times 7, that gives us 105 minus 102, which is actually 3 over 15. And 3 can go, which gives us 1 over 5. So y3 equals 1 all over 5. So y3 is equal to 1 divided by 5. Okay, so we've now been able to find the values of matrix Y. So we're going to now have, let's take this off. So having been able to find matrix Y, this is going to be equal to y1 is 4, y2 is 7 over 3, and y3 is 1 over 5. So 7 over 3, 1 all over 5. Now we know the matrix Y. So since we know the value of Y, we can now fall back to equation 4. We know the matrix Y. We know our upper matrix. What we are now left with is the variable matrix which we are looking for. So this now helps us to find our variable matrix. So we can take this off. So remember, we are now at equation 4, matrix Y, which is 4, 7 over 3 and 1 over 5 is equal to upper matrix times variable matrix. And we already know our upper matrix. Here's our upper matrix. Okay, so is our Y equals upper matrix, which is this. We'll simply put it down here, multiply by V, which is the variable matrix, and the variable matrix is X, Y, Z, which is what we are looking for. So therefore, we are going to have that Y 4, 7 over 3, 1 over 5 is going to be equal to, so we perform our multiplication once again here. The whole of this row multiply the column. So I have 3 times X, which gives me 3X plus 2 times Y, that's 2Y plus 7 times Z, that's 7Z. We'll move now to the second row. 0 times X, which is 0, plus 5 over 3 times Y gives us 5 over 3Y plus negative 11 over 3 times Z. So this can be negative now. So minus 11 over 3Z. We'll move now to the third column. 0 times X is 0, 0 times Y is 0, negative 24 over 15 times Z. We'll have negative 24 over 15Z. So just like we said, if two matrices are equal, it means each of their elements in their respective positions are equal. For this now, we will start from the very last element, or the very last column, or the very last row. Okay, we'll start from the very last row for this. So 1 over 5 is going to be equal to negative 24 over 15Z. So this helps us to find the value of Z. So 15 will simply cross multiply from here. 5 multiplies 24, 15 multiplies 1. So that gives us 15. Or simply divide 15 over 5, please. Yes, that's better. Equals negative 24Z. I think this is better. So 15 over 5 gives us 3 equals negative 24Z. So we make Z subject. Z is now going to be equal to negative 3 over 24. And this is going to be negative 1 all over 8. So the value of Z is negative 1 over 8. Z equals minus 1 all over 8. All right. We move now to the next row, which is row 2. So the whole of this row 2 is equal to 7 over 3. So we have 7 over 3 equals, here I have 5 over 3y minus 11 over 3z. So I know what z is. So 7 over 3 is equal to 5 over 3y minus 11 over 3. Z itself is minus 1 all over 8, right? Yes, minus 1 over 8. Okay. So 7 over 3 is equal to 5 over 3y. Negative is plus. 3 times 8 is 24. 11 times 1 is 11. So simply send 11 over 24 over to this side. So I have 7 over 3 minus 11 over 24. So we equal to 5 over 3y. Okay, the LCM here is 24. 24 goes into 3 is 8. 8 times 7. 8 times 7 is 56. So we have 56 minus 11 equals 5 over 3y. So 56 minus 11 gives us 45 over 24 equals 5 over 3y. So I think from here, 5 can go into 45. 5 goes into 45 gives us 9. 5 goes into 5 is 1. 3 goes into 3 is 1, 3 goes into 24 is 8. So it means that y is going to be equal to 9 all over 8. So it means y is 9 over 8. So our y equals 9 all over 8. Can anything go? No. Okay. Finally, we'll move now to the first row. 3x or 4 is going to be equal to 3x plus 2y plus 7z. So 4 is equal to 3x unknown plus 2y. Y is 9 over 8. 2 times 9 all over 8 plus 7z. Z is negative 1 over 8. Negative 1 all over 8. So 4 equals 3x. 2 goes into 8 is 4. So I have plus 9 over 4 minus 7 over 8. Okay. So I'm going to have 4 is equal to 3x. The LCM between 8 and 4 is 8. So plus 8. 8 goes into 4 is 2. 2 times 9 is 18. Minus 8 goes into 8 is 1. 1 times 7 is 7. So 4 equals 3x. Now 18 minus 7 is 11 plus 11 all over 8. So less than 11 over 8 here. I have 4 minus 11 over 8 equals 3x. LCM here is 8. 8 times 4 is 32 minus 11 over 8 equals 3x. 32 minus 11 is 21. 21 over 8 equals 3x. So 3 can go into 21. 3 cancels 3 is 1. 3 goes into 27. 21 is 7. So this means that my x is actually 7 all over 8. So x equals 7 divided by 8. Alright guys, so that's how to employ the lower and upper decomposition method to find the systems of this given equation. So for that equation, x is 7 over 8, y is 9 over 8, and z is negative 1 all over 8. I hope you find this video very interesting. Please do well to like the video, comment nicely, share to your friends, and if you're new to the channel, do well to tap the subscribe button. I will see you in the next video with another amazing example on this topic. Cheers.